All right, thank you for trying yesterday's homework. The key is that you try it. I wouldn't expect you to get everyone perfectly the first time, but go ahead and check your answers. If you need more time to check, I will also put this answer key on haiku. And if you have any questions, I'd be happy to answer those tomorrow too. We are going to start the new lesson today, which is really similar to the yesterday's lesson. Here we go. Except that today, instead of simplifying an expression, you're actually going to know what the end answer is. And so your answer is just the work showing getting it there. I just want to show you an example of what I'm talking about. We're basically going to just, in a way, prove that this is true. We're going to verify that sine squared plus cosine squared divided by cosine squared times secant squared equals 1, no matter what theta is. And some of the keys to doing this well are to, this is definitely, you only want to work with one side of the equation at a time. If you're adding something to both sides, you're doing it wrong. This is not really an equation that we're trying to solve, it's something we're trying to verify. I'm just going to do an example, and then these guidelines will probably make more sense to you. I'm also going to do a few more examples tomorrow. So this is kind of a 2-day lesson. We'll just get a few so that you can get started on the assignment and have an idea what you're doing. So one of the key points is that you want to start with the more complicated side of the identity. And so which one's the most complicated? That would be this one. And so I'm only going to work with that one, and I'm basically going to simplify it until it turns out to equal 1. So I'm just going to take this side of the equation and start applying known identities to it. For example, I know that sine squared plus cosine squared is equal to 1. And on the bottom, I've got a cosine squared and a secant squared. I think a good idea there would be to write that as cosine squared times secant squared is 1 over cosine squared. So this temporarily looks kind of horrible, but if you see where I'm going with this, on the bottom of this fraction, do you see how the cosine squares will cancel out? So then I just wind up with 1 on the top and 1 on the bottom, and that does equal 1, so I verified that that's a true identity. That's the basic idea. Here's another example. Again, I'm going to want to start with the more complicated side. That would definitely be this one. And this one's giving me the feeling that I want to add these fractions together like common denominator style. So let's do that. Alright, so on the top of this fraction, once I add everything together, it's going to be 1 plus cosine beta plus, from the other fraction, 1 minus cosine beta, and on the bottom is my common denominator. Alright, on the top, I've got a plus cosine beta, a minus cosine beta. I've got 2 on the top. I think I'm going to FOIL this one out on the bottom, because I know that when I FOIL a plus and a minus of the same type, do you remember the outside inside will cancel? So first would be 1 times 1. Outside is going to be negative cosine beta. Inside is going to be positive cosine beta. Those cancel. First outside, inside, last is going to be cosine beta times negative cosine beta. Alright, now this is reminding me of my sine squared plus cosine squared equals 1 identity. That's one of the Pythagorean identities. Only I need to rearrange it a little bit. And so now I'm seeing that 1 minus cosine beta, this bottom part, that's the same thing as sine squared of beta. And that's just 2 times cosecant squared of beta. And we just verified that that would be true then. This is the main idea. So really it's very similar to what we did yesterday. We're just simplifying the more complicated side and then hoping it looks like the more simple side. Let's just do one more, and then I want you just to try some. We'll do more examples tomorrow. So I'm thinking this is the more complicated side. Sometimes I actually don't know exactly what to try, but trying something and screwing it up sometimes shows me what I should have tried instead. So I have two options here. I feel like I could FOIL these two terms together. I also feel like maybe I could do some sort of Pythagorean identities, since they both kind of look like the squared with the ones. So I just have to decide which one I want to try first. And I think I'm going to try, let's go Pythagorean identities. So for the secant squared one, that's reminding me of this one. Only I need to rearrange it a little bit. And so secant squared x minus 1 is going to be equal to tangent squared x. I like that, so let's try it on the sine squared plus cosine squared identity for the other term. This time I want it to say sine squared minus 1. So I'll boot that cosine squared to the other side. So just rearranging again. And so then I figured out that this would equal negative cosine squared. Alright. That's simpler, but it's still not equal to negative sine squared. So maybe here's another technique that I told you about yesterday. It still applies today. If you change everything to sines and cosines, remember the quotient identities. Look on your sheet if you don't remember. But tangent squared is sine squared over cosine squared. There go the cosine squareds. So I have sine squared times negative 1, that's negative sine squared. That's what I was trying to show, and so I'm done with that one. You guys are just going to do your best. This assignment is officially due on Monday, but I want you to work in class today, kind of compare with each other, help each other, and I will see you tomorrow.